Assalamualaikum and hi. Today we would like to present our assignment 1, coal-fired power generation. Introduce my group members. First, Nurul Amira Nadia binti Mat Isa, BS 132310112. Second, Kamaruzaman bin Johari, BS 04202002. And me, Nurul Syazwani binti Amran, BS 13231013.
Assalamualaikum and greetings everyone. In this video, we are going to explore how electricity is generated using coal, one of the most widely used energy sources in the world. Despite the global shift towards renewable energy, coal-fired power plants continue to play a major role in supplying consistent and reliable base load power, especially in developing nations. Coal is a fossil fuel formed from ancient organic matter, and it contains a high concentration of carbon, which make it an excellent source of thermal energy when burned. This energy is harnessed using a thermodynamic process known as the Rankine cycle, where thermal energy is converted into mechanical energy and then into electrical energy. We all walk you through each stage, starting from coal combustion in the boiler, the generation of high-pressure steam, the rotation of the steam turbine, and the production of electricity via the generator. We will also touch on important components such as the cooling system, feed water cycle, and emission handling unit. To make it even more relatable, we will show a real example from Malaysia, TNB Kapar, one of the largest coal-fired power plants in the country. By the end of this video, you will understand not only how the process works, but also the advantages and drawbacks of using coal in power generation, especially from an engineering and environmental perspective. Let's dive into the science and engineering behind coal-based power generation.
Hi, my name is Nurul Syazwani binti Amran. Today I will be presenting the basic construction of coal-fired power generation. We will go through the major system and components that make up a typical coal-fired power plant and how they are arranged to generate electricity efficiently. Coal-fired power plants remain one of the most common methods of generating electricity worldwide. While renewable energy is growing, coal is still a backbone in many countries due to its reliability and base load capacity. Now, let's now explore how these plants are physically constructed and what systems are involved. At a high level, a coal-fired power plant has several main areas. First, coal handling system. Second, boiler furnace. Third, steam turbine. Fourth, generator. Fifth, condenser. Sixth, cooling system. Seventh, transformer. And lastly is transmission line. We begin with the coal handling system. Coal is delivered to the plant via rail or truck and unloaded using wagon, triples or grab buckets. It is then transported by conveyor belt to crushers where it is broken down into smaller particles. The crushed coal is stored in bunkers or silos before being fed into the furnace. Next is the boiler system, also known as the furnace. Here, pulverized coal is burned at high temperatures to generate heat. This heat turns water inside wall-mounted tubes into high-pressure steam. Components like superheaters and economizers are used to increase efficiency by preheating steam and water using waste heat from the flue gas. Then we move to steam turbine. High pressure steam flows into the steam turbine, which has multiple stages: high, intermediate, and low pressure. The steam pushes against the turbine blades, causing the shaft to rotate. This rotation provides the mechanical energy needed to generate electricity. Then we move to generator. Generator is to convert mechanical energy from the turbine into electrical energy. And the turbine shaft is connected to a rotor inside the generator, and the rotating magnetic field induces electricity in the stator windings. We move to condenser. Condenser converts exhaust steam from the turbine back to water, and it uses cooling water to absorb heat from the steam, and the condensed water is returned to the boiler. After that is cooling system. Cooling system is removes excess heat and release into the atmosphere. When water cooled system is like use river, lake or sea water. Transformer. A transformer is used to step up, which is increase, or step down, decrease voltage levels in an electrical power system. And then transmission line. Transmission line carry high voltage electricity over long distance from the power plant to substation near load centers. The high voltage minimizes energy losses during transmission.
Hi and Assalamualaikum. My name is Nurul Amira Nadia, and today I will be talking about the operation and basic principle of a coal-fired power station. Let's go through of how electricity generated from a coal or charcoal. Number 1, coal supply. Coal or charcoal is stored in a silo and sent it into the boiler using a conveyor belt. Number 2, combustion in boiler. The coal is burned to produce heat, which turns water into high pressure steam. Number 3, steam to turbine. The steam flow into a turbine and the pressure make the turbine spin. This create mechanical energy. Number 4, electricity generation. The turbine is connected to a generator, which changes mechanical energy into electricity. Number 5, cooling and condensation. After that, the steam is cooled in a condenser using cooled water and it turns back into liquid. Number 6, water recirculation. The water is reused by sending it back to the boiler. This forms a closed loop. Number 7, transmission. Finally, the electricity is sent through power lines to homes, schools, and factories. Next, basic principle of the power station. Let me explain the basic principle behind how the power station works. The process starts with the chemical energy in a coal or charcoal. When we burn the fuel, it releases thermal energy or heat. This heat turns water into steam, which moves the turbine and creates mechanical energy. Finally, the mechanical energy is converted into electrical energy by the generator. This whole process is known as the steam turbine generator system. On this slide, show 3 major coal-fired power plants in Malaysia. On the left is the Sultan Azlan Shah Bersia Power Station located in Perak. In the middle is the Tanjung Bin Power Station, which is the one of the largest coal power plant in Malaysia located in Johor. And on the right is the Manjung Power Station, also in Perak, known for using advanced ultra supercritical technology to improve efficiency. Now, I would like to share some examples of a major power generation site in Malaysia, especially those that use coal or mix of fuel. These power stations play a big role in supply electricity to the national grid. Number 1, Tanjung Bin, Johor. Located in Johor, this is one of the largest coal plants in Malaysia with 2100 megawatt. Operated by Melaka, it supports the national grid. Number 2, Jimah, Negeri Sembilan. Jimah Power Station near Port Dickson use import coal and generate about 1400 megawatt. It operated by Jimah Energy Venture. Number 3, Manjung, Perak. Manjung is one of the most advanced coal power station in Southern Asia. It produces over 410 megawatt and it run by TNB Manjung. Number 4, Kapar Energy Venture, Selangor. Located in Selangor, this plant use coal, gas and oil. It produces more than 240 megawatt and is a joint venture between TNB and Melaka. Number 5, Sultan Salahuddin Abdul Aziz, Selangor. Also in Kapar, this coal and gas plant produce about 2420 megawatt. It help power a large part of peninsular Malaysia. These plants show how coal and other fuel are used to generate electricity at a larger scale in Malaysia.
Let's look at the advantages of using coal-fired power station. First is reliable, works day and night, unlike solar or wind. Second, high output can power thousands of homes and industries. Third, stable supply, not affected by weather. 4. Job creation, support job in mining, transport and operation. But there are also some disadvantages that we need to consider. First is air pollution. That means they produce harmful gases and smoke. Global warming releases a lot of CO2. Waste leave behind coal ash. High water usage, need a lot of water for cooling. Non-renewable, coal will eventually run out. So, what is the conclusion? So, the conclusion is coal power is strong and dependable, but it's harm the environment. That's why many countries are shifting to cleaner energy like wind and solar.
That's all from our group. Thank you.